order
Yeah.
reaction.
But I won't be doing it. You guys only will be doing it.
Okay.
Again, it all starts with a reaction. So let's say AA plus BB, or like let's just take reactants gives products. So reactants gives products. What is the rate law for this? Like if this, you know that this is a 0th order reaction. What is the expression for the rate of a reaction? So rate will be equal to
Minus dr by dt
is yes.
is equal to dp by dt.
Will be equal to that will be like rate of decrease of reactant equal to rate of this thing. But how does it depend on the concentration of the reactant?
Oh yeah. So then we look at that what is it called? I'm sorry.
Check your notes.
Hello.
Previous session ke notes and tell me.
Yes, ma'am. So then we look at the x or y's value, and x plus y is equal to 0 for the 0th order reaction. So r raised to 0 is 1. So
r raised to the power 0.
Yeah.
So this is the expression for the rate of the reaction. It's a 0th order reaction. 0th hai, that's why the number is 0 over here.
0.
Okay. Ansh, Shantini, you guys getting it? Like following?
It's following.
Yes, ma'am.
Okay. No, I can't see your faces also, so I don't know if like it's making sense or not following here. Okay, so dr by dt will be equal to concentration of the reactant raised to the power 0. So that's what 0th order reaction is. So now instead of being it like, let's try to find the integrated form of the reaction. So to get rid of the derivatives, what you do is integrate on both sides. We'll just rearrange this a little bit. K bhi hona chahiye. We've forgotten rate constant. Okay. So minus dr will be equal to k into r power 0 is 1 and dt agar idhar gaya, so this will be dt. I'll take minus also on the other side so that concentration will be there. Okay, so now if we integrate this on both sides, what will be the next step?
R is equals to kt plus c.
Equal to kt or something else?
Minus kt plus c.
Minus k into t plus c. Do you guys know what these variables stand for? What is r in square brackets?
Ma'am, can I answer or like somebody else wants to answer?
Anybody?
I didn't hear your question. Can you repeat?
What do these variables stand for? What is R?
The reactant.
Reactant ka kya?
Concentration.
Concentration, yes. So this is concentration of the reactant. This keeps changing as time goes by. K is?
Rate constant.
The reaction constant. Rate constant.
Rate constant.
T is just a constant.
Huh?
Time.
Time.
I said C is just a constant.
It's not just a constant, it is time.
C for cat.
T, acha. Yeah. T is the constant, integration ka constant. Constant from integration. Okay. All right. Now this makes sense. This is what we are tracking key as time goes by. How does the concentration of the reactant change? But C is like an unknown random mathematical thing that came up, right? how can we find out the value of C?
At time is equal to 0, the concentration of the reactants is equal to C.
Yes, at when t equal to 0, that means this is at the initial, like when we just took the reactant, we know that concentration of the reactant will be equal to R naught. Like this is a known quantity and this is a constant because that's literally what you're taking in the test tube. So if you substitute the values, you get concentration equal to minus K into 0 plus C, which means at time equal to 0, because reaction ka concentration is R naught, C will be equal to R naught. Okay. So for a 0th order reaction, if you have to find out the rate of a reaction, if you have to find out the concentration at any given point of the reaction, this is the equation you'll follow. R equal to minus KT plus R naught. So this is the main equation. Okay. So now we'll do some analysis on this thing, just like how we did it in solutions and all the other chapters. Isme, what all are the variables? Like what is changing over the course of a reaction?
Concentration of the reactants.
Yes. So this
and the time.
And time is also changing. So these two are variables. K and R naught are constants. It won't change
Yes,
at
ma'am.
any given point in the reaction. So let's say this is Y and this is X, because time is independent or uske basis pe rate of the reaction is changing. So based on this, what sort of
I'm sorry. Time is independent of.
it's independent of
You
everything.
said something. Yeah. Okay.
It's an independent.
I missed it.
Yeah, that's why it's X. And
Okay.
this is dependent on time, because as time goes by, this keeps decreasing in the reaction. So we assign this as Y. What happened, Riti? All good, like following?
Ma'am, just to confirm,
All
this
good.
value of X and Y has nothing to do with the experimental values that we found. No, they're completely different, right? Okay.
So this is just to like make you guys understand. So based on this, what sort of an equation is it? Like, are you familiar with this type of equation?
Y is equal to mx plus c. That gradient wala
The
or some
line
weird
equation of
coordinate.
line.
Yes, line equation. Yes, thank you.
Yes.
What are you saying, Midali? Seriously,
I have
get
no
your
idea
math-
what I was saying.
I get you're not a math student, but this we have done in 10th standard.
I still don't remember it.
Okay.
No, but I still remember the equation, man. I should get like points for that.
Yeah.
Yes, exactly.
Okay, so let's put it on a graph. Y equal to mx plus c. What will that graph look like? Wait, let's put the. So this is x axis, right? So this is the time ka variable like axis, and this is the concentration ka axis. So what will the graph between concentration and time look like?
From that, I don't know.
Math students, Ansh, Dhriti,
Exactly.
y equal to mxc plus c ka graph. What is it?
Isn't it?
It's a line.
Parabolic?
It can be any. No, it's not a parabola. It's a straight line. It can be
Oh.
any sort of straight line. Down, up, horizontal.
But it's a
vertical.
straight line.
It's a straight line.
It's a straight line, correct. Now, look at the constants you have over here and then tell me what sort of a straight line it would be.
It would be
It
downwards.
will be
Minus k hai.
minus.
Upward.
So minus x na x का value minus आएगा. S no one ऐसे.
Should I
Why
start?
would it be that? That
So-
means it's increasing, but it's decreasing.
Minus x is on the left side.
Slope is minus k. So tell me, will it be like
It'll be like that.
or
Down,
like
down. No, the second one.
ये वाला? नहीं, ये वाला.
हाँ, second
A,
one.
B,
A.
Downward sloping.
downward sloping. Very good. Where should I place the line? Will it intersect the y-axis, or should I start off from somewhere over here?
It is plus C, right? So it will intercept the y-axis at some point.
Correct. So intercept the y-axis matlab x ka value is 0. Do you know what point that is? Can you figure out what the y-intercept is?
C.
See kya hai? Like apply it over here. We're not
Oh,
doing
R naught. Acha, sorry.
yeah. So the
R naught.
y-intercept represents the initial concentration R naught, and iska slope will be equal to
R rate of the rate of the reaction.
no. Look at the equation. What information is the slope giving you?
Oh, this time.
Time?
And X, right?
Time is a variable either.
No, y, the R, the concentration of.
Is
No.
wait.
What is the slope of this line? You have y equal to mx plus c. अगर कुछ random line है y equal to mx plus c, तो इससे how will you find out the slope?
The gradient.
Giving us K.
You guys did straight lines in math, right?
I think so.
Oh my god. And Shantanu, what do you guys say? Like slope कैसे find
Well,
out?
the slope will give you the rate constant.
There you go. Slope is equal to k. So y equal to mx plus c में x and y are variables. M is the slope and c is the y-intercept.
Ah.
So same thing applied over here. This is one variable. Time is a variable. तो time का x का coefficient m. तो यहाँ पे जो भी है, that the like minus represents that it is downward facing, but the magnitude of it, that will be equal to the rate constant k. Slope equal to k. So this is the analysis. So variation, it's going to be like this. As time goes by, concentration decreases. What other information can you get? So slope is equal to minus k, that is equal to initial concentration minus the concentration at any point of time divided by that point of time. So the gradient, how do you find out slope? As you said, like take any, if at time t, the concentration is R naught, R, then it's y2 minus y1 divided by x2 minus x1. So that's what it is. So if you are tracking a reaction, the concentration is something that you can measure at any given point. So just by tracking the concentrations, you can get the rate constant at that particular temperature. This is the formula to find the rate constant for 0th order reaction.
So ma'am, this can be applied when we have like a graph given in the question and then we need to find the rate constant or something or the other.
Yes. So if a graph is given, you can easily get the values of this. If you're not given a graph, like if you're just given that, oh, I took 1 mHCl for neutralization. After some time, we found out that the concentration was 0.05 m. Then what is the rate constant of that reaction then? Yeah. If you know the time, if you know the concentration, you can find out. Okay. Let me see if there's any example problem that you can do.
Ma'am, can you give us a minute to copy that down?
Yeah. You can apply this instead of initial concentration. You can take it at any other point also. So if you have like at T1, T2, it's going to be concentration at, so R1, R2, then R1 minus R2 divided by like T2 upon T1. So basically, yeah, in any way, the gradient is going to give you the rate constant. Okay, so let me know once you guys are done noting this. There are some special points about the rate constant which we'll discuss. Like where do we find zeroth order reactions, real life examples, things like that.
Done, ma'am.
Okay.
Done, ma'am. Ma'am, I'll just be back. I need to use the washroom.
Yeah. Ansh, Shantanu, let me know. And you guys being really, really quiet, like tell me if you guys are following any place you're not understanding. So the chapters that you guys had done in school back in term 1, surface chemistry, all of that, is it very, very hazy, like completely zero, or do you have any, even a little bit of idea about those concepts?
Ma'am,
Negative.
electrochemistry D and F block, I still have like a decent idea about what the chapter is about. Surface chemistry is 0.
Okay.
Other
Ma'am,
than that,
negative.
Negative. Okay.
Yes.
Cool.
Also, ma'am, for this chapter, I'd have to revise equilibrium and thermodynamics from 11th standard, right? Because
Equilibrium.
it was on the list that you gave me in term 1.
Like it's not prerequisites as such, but the concepts are so related that you may come across questions referencing that. Like you have zero order reactions, first order reactions. One of those reactions could be, problem may if you had an acid dissociation thing. Like pKa and all that apply to that, right? And they are rate constants for those particular reactions, right? So that way, if there's a sudden reference, it's good to know the basics of that. Yeah.
Okay.
Purely from an application point of view, rather than, like that's not the basics of these, but the concepts are pretty related. So it's good to know.
Okay. Okay.
Okay. You guys done? Should we go ahead?
Yes, ma'am.
Okay. Shantanu?
Yes, ma'am.
Cool. Okay. So let's get back to the basics, like definition of zero order reactions. So basically rate is equal to K, which is a constant, right? Basically what zero order, like the significance of zero order reactions is that the rate is independent of the concentration of the reactant. Okay. So it's not like, whether you take a large amount of the reactant or small amount of the reactant, the rate is going to be constant. You can't speed up the reaction by taking a larger amount of it. Okay, so that's like an important factor to know. So suppose you're manufacturing something. Actually, let's get into the examples. Okay. So real life occurrences, like where do you find zero order reactions, are since they are independent of the concentration of the reactant, you'll usually find them in enzyme catalyzed reactions. So body processes, for example. So wherever, like where you need an enzyme for that reaction to take place, it doesn't matter how much of the reactant is there, like the rate will always be constant. And like basic reactions that occur on metal surfaces, like hydrogenation, for example, that way. Yeah. So essentially independent of concentration, but it depends on other factors. So it depends on things like how much of the catalyst is available or how much of the surface area is available. So if you want to speed up these kinds of reactions, you need to look at these other factors rather than the concentration itself. Okay. So for example, decomposition of ammonia over platinum catalyst. Yeah. So you can't really affect the speed, doesn't matter how much ammonia you take. It depends more on how much of the platinum surface area is available for this reaction to be affected. So ammonia, NH3 gas, heat it up to 1130 Kelvin.
Ma'am.
Platinum, yeah.
So enzyme catalyzed reactions and reactions that occur on metal surfaces, all of the reactions that come under these subheadings are of zeroth order.
Wouldn't say all of them, but typically
Most
zero
of
order
them.
reactions tend to be these sort of reactions. Like if
Okay.
you take any,
So they're not like examples as such, but like they do fall under the category.
yeah, like where would you find zero order reactions? So these kind of reactions are zero order. Yeah. So the rate of this particular reaction, even though there is a reactant, it's independent of it. It's basically a constant. Okay. Another example is thermal decomposition of HI. Again, this takes place on gold surface. Same funda, like HI decomposes into hydrogen and iodine on gold surface. That doesn't depend on this. Then decomposition of nitrous oxide also. So N2O, gaseous. This also happens on platinum. If you were to balance it, oh, it's like water. Yeah. Oh, and enzyme catalyzed may reaction, like the thing is, oxidation of ethanol in humans, in human liver. So in this case, the enzyme that enables this reaction, that catalyzes this reaction, is dehydrogenase. Oh, that makes sense.
Ma'am, you've written rate is equals to K, NH3 naught is equals to K. I didn't get that.
Not nay, this is to the power 0. 'Cause
Oh,
these are
sorry,
examples
sorry.
of order reactions.
Yeah, sorry.
So fun fact, I'm not sure if we mentioned this when we were doing alcohols, but in the human body, ethanol, like alcohols, get oxidized to aldehydes, which is why methanol is dangerous, it's poisonous, because that gets oxidized to formaldehyde, and formaldehyde is like literal poison. So the cure for, if by mistake you ingest methanol, the cure for it is to just pump that person with ethanol, because in the liver this takes precedence. So while the liver is busy processing this, you get all the methanol out, pump the stomach.
But like, why does the liver forget about methanol?
Basically, like, preference is for ethanol, just like how hemoglobin has a preference for carbon monoxide, which is why that poisoning happens.
Yeah.
Like for this particular oxidation reaction, the preference is for ethanol. So if you have methanol versus ethanol, ethanol is the one that gets oxidized preferably.
And how is the methanol like passed? Like, does it even reach? Like, okay, it does reach the liver, but it just like simply processes outside.
Yeah,
There's no
at
conversion
that
taking place.
site, like wherever that happens, this enzyme and all of that. Yeah.
Whoa, that is interesting.
And it's interesting. The enzyme is dehydrogenase because you're literally removing this hydrogen and then making it a double bond O. Naming.
I just have switched off my camera for 5-7 minutes. It's lagging, that is why. Once the net becomes better, I will switch.
So again, let me know once you've written down these 4 things, and that's it. There's just one more point about zero order reactions that we will talk about, and then we'll get to first order.
How much more is left in this chapter again?
This is the meat of the chapter, zero order, first order, deriving these equations. After that, we look at temperature dependence, and temperature dependence is just one equation. I think it was excluded also, but we'll look at it later. And catalyst again, it is, you look at catalyst more in surface chemistry because that's what it, but we look at the effect of catalyst in terms of the energy changes. So
like activation energy decreases by like a huge amount. Okay.
So that's more theoretical, sort of, if I can call it that. Yeah. So zeroth order, first order, these are like the meatier parts. If you get questions, numericals, things like that, this is what is based on.
Done.
Yeah. Dhriti and Shantanu, once you guys are also done, I will look at that.
Just a second, it's almost done.
Okay.
Yes, ma'am, I'm done.
Done? Okay, there's one more example I just saw. Even chlorination reaction of alkanes, halogenation of alkanes, the free radical substitution reaction. So
It's
that
zeroth order.
is zeroth order. It depends on the availability of light. Doesn't depend on how much of H2Cl.
Done, ma'am. You can continue.
Any reaction that depends on like the availability of something else rather than the concentration of the reaction is zero order.
We can generalize it 100%, but yes.
Okay.
Yeah, if it is independent of the concentration, it's definitely going to be zero order. Yeah.
Yes, ma'am.
Okay. And Shantanu, what about you guys?
Done, ma'am.
Done. Cool. Shantanu?
Yes, ma'am. Done.
Okay. Huh. So one more point about zero order reaction is we saw that it's a straight line, right? It's not that like as the concentration of reactant, like once it reaches a certain point of time, basically the backward reaction kicks in. So it's not a straight line till the concentration becomes zero. Like at extremely small concentration, this kind of curves and it becomes like parallel to the time axis. See? So like the reason why this is so is again, like, you know, it's basically at the point where at extremely low concentrations, the whole of the catalyst surface is not covered. Like imagine this is the whole surface area you have for the reaction to take place. But if there's only a little bit of reactant that's like covering only this much, then it does depend on the concentration of the reactant, because the more reactant you pass through, the more the reaction can take place. But this is an exception, or you know, it's kind of a deal only at extremely low concentrations. So once you cover the whole catalyst ka surface area, it doesn't depend on how much ever reactant you have.
Okay.
Yeah. So that is the reason why that takes place, and yeah, that's the point. Just note it down. Oh, I skipped one page. Never mind. Yes. All right. Next, we'll move on to first order reactions. So we'll give it the exact same treatment as what we did with zero order reactions. Okay. So what's the first step that we start off with? First order reaction mein? Let's take the same
R is equal.
same thing. Reaction
R
reactant here.
converts to P.
So then rate will be equal to.
So, ma'am, now rate R will be equal to 1, right?
R will not
X
be
plus Y is sorry. X plus Y will be equal to 1. R will be raised to 1, correct?
correct.
Okay.
So,
So minus dr by dt is equals to K into R raised to 1. So R,
R.
either way.
R raised
Yes.
to 1.
Okay.
So next step, like just rearrange this a little. R will
Minus
be equal to minus K into R into dt. Rearrange it again. We need to integrate it because that's what we are doing in this whole thing. We're finding the integrated.
So now we'll integrate it on both the sides, right?
So integrate करने से पहले, get all of the like same variables on one side. Square brackets.
Okay.
When we look
So
at it, यहाँ पे this is derivative of concentration of R, right? So everything related to this particular variable, keep it on this side. So you get dr by concentration of R. And if at all there was time also, then everything related to that will be on this side, K into dt. Now it is ready for integration.
So ma'am, we went from dr by dt is equals to minus k r raised to 1, correct? After that, we took the dt on the other side, and then looking at the same variables, we took the r from left hand side to right hand side. No, right hand side to left hand side.
Yeah.
Okay.
Mathematics, just rearranging so that we have the same
Yeah.
variables on one side. Okay, math people, I know you guys had introduction to integrals last week. So now you guys have to tell me what is the next step. So dr upon r integrate करने के बाद क्या, like what do you get?
R raised to 2 by 2.
dr into r नहीं है.
No.
dr upon
Oh yeah, correct. Can it get cancelled? It
Yeah.
can't get cancelled.
See?
It's R by integration of R.
Huh?
Yeah, because the D. No.
So basically 1 by x dx का integration. Think of it this way. So what is the result for this?
So it becomes R raised to minus 1 D. Okay, 1 second. R raised to minus 1. Log R. Log R.
Log or ln, like logarithm to the base 10 or natural logarithm?
Natural log.
So 1 by x, basically if you have it in the denominator, this is ln x. So apply that, you get ln natural logarithm of r is equal to, यहाँ पे क्या होगा?
Minus K and T. Minus K.
Minus kt plus c. Don't forget about the integration constant. Yeah, so this is basically our first order reaction. Again, just like with zeroth order, figure out what should be the integration constant. Uske liye get rid of t. At t equal to 0 initially, when brackets, when the concentration is equal to r naught. So apply these values, you get c equal to natural log of r naught. So once we plug all the values you get, so basically your first order reactions के integrated form of the reaction is ln r is equal to minus kt plus ln r naught. Yeah. So the whole reason why we are doing this derivation is we're using the expression that we know for rate of a reaction in order to help us figure out the other factors of the reaction, like rate constant. अगर rate constant पता है तो you can theoretically predict, okay, 5 seconds के बाद कितना रहेगा concentration, all of that stuff.
Okay.
ठीक है. So again logarithm है, इसको थोड़ा सा rearrange कर ले. So what we did with zero order reaction is, once we found this out, we wanted to get expression for the rate constant. So let's do the same thing for this also. Analyze.
So we'll like
graph and then-
so we'll make a graph.
yeah. So this, if you want to find k specifically, इसको rearrange करके देखते हैं. kt equal to ln of r naught minus ln r. So that will be equal to, what is log a minus log b? Do you remember? No? What about the math people?
Ma'am, can you like take a lecture on log, or can I like meet you personally for 30 minutes?
A better reference would be like a math person, because I also remember this only purely in the context of, these derivations.
Yes, ma'am. I only need that much knowledge. I don't need any more knowledge.
So identity here, log A minus log B is equal to log of A upon B. Yeah. So this will be equal to ln of,
R naught by R. So we need like we didn't have to like draw a graph for it.
we will get to again logarithm hai na, so then it's like your typical logarithm ka graph aise rahega kuch.
Okay. And ma'am, what about the T?
So one more step, that is equal to, or basically if you want to get expression for rate constant, that is equal to 1 by T ln of R naught by R. Okay. So basically this is your primary expression. Using this, there's lots of other things you can do. Suppose you don't know the initial concentration, you just know it. What is the concentration after 3 seconds and what is the concentration after 5 seconds? Then you can substitute those values and then figure it out. So that's another way to do it.
Okay.
Okay, so this is like the expression for rate constant. Alternate expression also I'll give you this. So k equal to, suppose you don't know at a time t equal to 0, you just know at 2 random times, then it will simply be t2 minus t1, then ln r1 by r2. So which formula you're going to use, which expression you're going to use, purely depends on what information you have at that point of time. That's it. Both are derived from the same thing.
Okay.
Yeah.
Done, ma'am.
Just 1 second, I'm doing it.
Another thing to help you guys with calculations, you can convert the natural logarithm into regular logarithm. What is the number, magic number that you use for that conversion?
10.
What do you multiply it by when you want to convert natural log to regular log?
I don't know that. We haven't done that.
Okay, we had come across this in electrochemistry also. 2.303. So by T.
So 2.303 into. Oh, so that'll make it log to the base 10.
Yeah.
Okay.
So this is like universal. If you want to convert natural log into regular log, so ln is basically 2.303 into log. So wherever you come across a logarithm based formula, right? Like not just this chapter, any chapter, any context, even in physics for that matter, like if at all you come across this, this is your conversion. Okay. Now, first order reaction, you'll get a lot of like application based things because now there is dependency on concentration also. Let me see if there's any questions based on this concept alone. Oh, good. There are a couple of problems. So before we start half-life, we'll do questions based on this. That way we'll get to apply this also. It won't be like information overload.
Mom, will you present the questions?
Yeah.
Okay.
Is everyone done? Like, are you let me know once you're ready to do the question, then I'll put it up.
Yeah, I'm done.
And Shantanu, you guys?
Ma'am, can you show the previous page for a second?
Yeah. In the meantime, like math integrals what all did you guys do? How much did you go over for integration?
Miss, we just finished the basics, like not a lot of it.
So basic matlab like x dx, x square dx, that way.
Yeah, all that, yeah. Trigonometric functions that we have done.
Okay, but logarithms and this you haven't come to yet.
No.
हाँ तो बताना चाहिए ना. You should have told कि no, you don't know, like you haven't covered this yet. I thought you might have done it. Yeah, I was asking you.
Miss, I thought this was just like, it's a part of the thing we have to do, so I just wrote it down.
Oh, okay. So +1 -1 लिख करके, right?
Yeah.
Yeah, I can see how it will get confusing because 1 by x matlab x power -1. If you do +1, ये तो 0 हो गया. And division by 0 is not defined. So yeah, just like once it's 1 by x, it becomes logarithm. Another thing, integral e power x will remain e power x because whether you differentiate or integrate, e power x will not change. All right, Shantanu, Ansh, you guys done? Kahan tak pahunche? What's happening?
Yes, ma'am. Done.
Okay, Ansh? Ansh Gupta, what?
Done. Excuse me. Done, ma'am.
Okay, any doubts, any place where you feel like it's gone over your head or something like that?
No, ma'am.
Okay, logically followed, right? Okay. So let's do the question. Example 1, यहाँ बहुत नीचे है. Let me zoom in a little bit. Consider a certain reaction. A gives products with K equal to 2.0 into 10 power -2 second inverse. Can you figure out what is the order of this reaction purely based on the unit of reaction constant? Or like just
It's
go over
first
the
order.
first order. Okay, good. Yeah. So now that you know it's
Yeah,
a first
looking at the units, it's first order because in first order it's 1 by t.
order. Yeah, because it gets cancelled on both sides. Yeah. So that's kind of how you gotta interpret the question. Then once you know that it's first order, you can put like k is given, time is given, initial concentration is given. So you just have to figure out the final one. And अभी यहाँ पे logarithms and all are involved, no? आज के अभी के लिए just use a calculator to figure it out. जल्दी हो जाएगा. I'll just get water. You guys like solve this question.
Miss, your screen suddenly blacked out. Can you stop sharing and reshare?
She's not here.
Yeah. What happened, Diti?
Miss, your screen suddenly blacked out on my screen. It's my network, I know, but
Yeah,
can
Abhi?
you stop sharing and reshare? Yeah, now I can see. Thanks.
Ma'am, I found out the value for like ln r is equals to the answer. So do I leave it there or like is there anything else that I need to do?
You need to calculate the concentration of A remaining, no? So you need to find that antilog of that.
Okay.
Actually, I told you like use a calculator. It'll make it easier.
Can you repeat that? You were like, I couldn't hear you.
Still, yeah, I said you can use a calculator. Acha, before that, are all of you able to solve it, or like is anyone stuck at any point?
No, ma'am, I'm able to solve it. I'm just mixed up a little in the calculations. Give me 2
Okay. And Shantanu, what about you guys? Were you able to identify what is given, what is to be found? क्या apply करना है?
Yes, ma'am.
ठीक है. And you're also solving, like, are you calculating or where are you at? Just a second. Okay, so consider this reaction. A gives products, K is given as 2 into 10 power minus 2 second inverse, matlab first order reaction. Then calculate the concentration of A remaining after 100 seconds. So T is 100 seconds and initial concentration R naught is 1.0 mole per liter. So first order reaction ke liye we have use log R, because calculators may generally, and even when you use log tables and all, to the base 10 is what you generally use. So use log R only. Will be 2.303 upon time is 100 upon time, sorry. So 2.03, 2.303. Let me just use minus log 1 is equal to minus k t divided by 2.303 is what you get. So log R is what we need to find. Log 1, logarithm of 1 is 0. So this will become 0. So 2.0 into 10 power minus 2 divided by into 100 second is 10 square divided by 2.303. So we just need to calculate this and this will get cancelled. So 2 divided by 3.303, anti-log. We have a scientific calculator. Okay, just to check the values, log R ka value, how much did you get? Mitali, Dhriti, Shantanu. Can't have scientific calculator here. Anyway, what is the value you got for log R before finding the anti-log? Is this what you got? Your calculation? 2 into 10 power minus 2 into 100 divided by 2.303. Mitali, you are under mute.
Sorry. So I did up till 1,
Yes,
2, 3, 4, the fourth step, but after that I couldn't
I
do
got the
anything.
minus log A. I didn't know how to do the
Anti-log. You guys, okay, you don't have log tables. You guys have Android phones only, right?
Yes, ma'am. I to have a scientific calculator also, but it's still not happening because I don't know how to figure out the anti-log thingy on the calculator.
वहाँ पे anti-log करके there's no button क्या?
No, see, there's log ka button, there's long ka button. Then I was like shift log, but it goes to 10 raised to something.
So sine, cos, log, tan, brackets, degree, ln.
Yes, exactly, same thing.
Then there is something called INV, inverse. Do you have that button? So like sine becomes sine inverse, cos becomes cos inverse, square root becomes square, that way.
Yeah, but ma'am, here, see, if for example, if I do sine and if I need sine inverse, then I simply press shift sine. So that becomes sine inverse.
हाँ तो
Log में ऐसा नहीं है. हाँ, so I did shift log, but it's 10 raised to something.
yeah,
But 10 raised to what? Like, can you see it? Can you see that?
okay.
This is what I'm getting. That is shift log. Shift log, I'm getting E something.
Shift ln is e power. Yeah, that is the natural logarithm. Let's see, wait. 2 divided by 2.303 is 0.86 something. 10 raised to the power 0.86 or 0.86 नहीं, minus 0.86 होना चाहिए. Where is minus? Minus 0.86 equal to 0.138. That's what you need to do. So whatever value at the end of this calculation you get, just press 10 raised to the power that particular value. You'll get, that is literally, that is what anti-log is.
Okay, ma'am.
10 raised to the, so the thing that I first showed you.
Yeah.
Okay.
So this you'll get approximate, that is annotation. So that is equal to 0.86 something. So to get, in order to get this concentration, you'll get 10 raised to the power. ये जो minus है, that also you need to include 0.86. So इसका जो भी value आएगा, that is your answer. You'll get 0.13 something. Okay. And Shantanu, where are you guys at? Like, is this the point? Like, यहाँ तक were you able to do it? Finding log A कितना है?
No, ma'am, I wasn't.
Okay, what happened? Like, where did you get stuck? Question पढ़ के, did you, like, what information did you get out of the question? Ansh?
You got K and you got the
ये है
you got the time.
Yes, so time equal to 100 seconds. Then initial concentration of A. So concentration of A, initial है, that is at time equal to 0. So A not होगा वो. That is 1 mole per liter. Abhi, in order to find the final concentration, like this is the whole reason why we derived all the expressions. Okay, so I'll just switch to the whiteboard. तो zeroth order के लिए, first order के लिए, when we did the integration, this is the reason why we did. So यहाँ से, if we know the rate constant, because that's constant for a reaction, for whatever initial concentration we take, after a certain amount of time, we'll get to know what is the concentration of that reactant at that point of time, how much is left. Okay, so this is for zero order reaction. Same is the case with first order reaction. We did the integration and everything so that we'll come to know at time t how much is the concentration that was of the reactant that is remaining. Okay. So if at all you come across these sort of questions, no, calculate the amount of reactant left after so and so time, or if at all you're given the final concentration, you need to find out the time. So any question with this sort of a situation where after some time itna reactant is left, so how much is left or how much time has passed, if this sort of a situation is what you have, these are the reactions you need to use. Now you have two expressions for it. Zero order reaction के लिए expression है, first order reaction के लिए expression है. Which one do you need to use? Usually in the question, either you'll be given whether a reaction is zero order, first order, or you need to figure that out from the information that's given to you. So here rate constant is given. Okay. Abhi zero order reaction ke liye, I'll just put it on the board so that it's easy. So zero order reaction ke liye, rate is equal to K into concentration raised to the power 0. That's it. Which means, what will be the unit of the rate constant? Ansh? So zero order reactions ke liye, what is the unit of K? Oh, some issue with the mic, I guess. You can put it on chat, Ansh, if
Ma'am, do I say it?
hang on, wait.
Or okay.
Huh. So this is basically molarity. So basically concentration, like whatever is given, mole per liter per second, right? Similarly, first order reaction may rate equal to K into the concentration of the reactant raised to the power 1. So which means in this case, what will be the unit of K? So rate is concentration per second is equal to K into concentration.
So concentration will get cancelled out,
So unit of K is
leaving us with second inverse.
So this would be the unit 1 by S or S power minus 1. So either if you're not given in the question whether it's a zero order reaction or first order reaction, this is how you figure out, like based on the value of K that is given in the question. Okay, so coming back to this, K equal to this second inverse, which means it's a first order reaction. So now you have all of the information you need. So use put the values of K initial concentration time in the correct equation. Solve the equation for whatever is the unknown value and you'll get your final answer. Okay.
How are we expected to do this in exam?
How do you guys manage in the previous thing? You would have log tables carried, right?
No, I mean, up till now, we haven't had
They don't allow log tables anymore. I mean, like they
yeah,
moved log tables.
That means
neither
you
have we
won't get
solved any
questions
questions.
then you won't get questions based on this. Either you'll be given in the question itself, sometimes you'll be given, right? Sine 37 equal to something, tan 30 equal to this. That way log of 0.86 will be equal to this. Aisa karke you'll be given. Or you can leave the answer logarithm of this equal to this much. Or you won't get these kind of questions. So you don't have to worry about it. So the next one, the following data were obtained during the first order thermal decomposition of SO2Cl2 thionyl chloride at constant volume. Now we come to our gaseous this thing. No worries. Everything is the exact same thing. Instead of using mole per liter and expression for constant, instead of that, you'll be
Atom per second.
Yeah, the partial pressure.
Atmosphere per second. I had said atom per second.
Atmosphere, basically you'll be using partial pressure instead of concentration. Okay, everything else remains the same. The information you're given at time t equal to 0, this was the pressure of SO2Cl2. And at time t equal to 2, this is the total pressure. Calculate the rate of the reaction when total pressure is at 0.65 atmospheres.
Great. So SO2Cl2 will give us SO2 and Cl2.
All of them are gases. Put some thought into it. See if you guys get any ideas, and then we will discuss. So when in doubt, see if you can work yourself backwards. Like rate of reaction. So rate is K into concentration of the reactant, or in this case, it will be partial pressure of SO2Cl2 over 1. So still you need to know what is K. You're not given K. So first you need to find the rate constant using this information that's given. And then add 0.65 atmospheres, no? So that you can put. See, so first step you need to figure out is how to get K from this information.
Ma'am, just to clarify the information, experiment 1 and 2, so they're like two separate things. It's not like after the first experiment was performed and after like 100 seconds of the first experiment we
No,
got
it is after
0.6.
100. No, it's the same
It's
thing.
after only. Okay, so it's like the same reaction, right? Okay, because if this is the same reaction, then I can use the first order reaction wala thing where I can find K directly, right?
Yes, but one thing you need to be careful is this is the total pressure. This is not specifically pressure of SO2Cl2.
But I can no, that I can't. No, but I can still do R1 by R2, right?
How? Like, do you have that information? You eventually you need to do R1 by R2, like R0 by R2, but you need to correctly identify what are the values of R1 and R2. So that's like the key in this particular question. That's where the twist is in this question.
Okay. So the total calculate the rate of the reaction, the total pressure is 0.65 atm.
Dhriti and Shantni, you guys made any progress? Like, kya ho raha hai? Figured out?
I'm still solving. Just give me 2 minutes.
If you're stuck, Abhi bata, we'll start discussing. But if you are already
I'm stuck.
okay.
Miss, I'm not stuck. I'm solving.
No, I'm stuck on how to find the individual values. I got how to get the final answer, but I don't know how to find the individual values.
Yeah. Get the okay. At time t equal to 0, what do you find in the reaction vessel?
The total pressure of
Let's say this-
SO2Cl2.
there you go. So this is basically your P0. So all of 0.5 atmospheres is from SO2Cl2 only. Okay. Then after t equal to 100 seconds, reaction has passed, which means you have a little bit of SO2, you have a little bit of Cl2 as well. So 0.6 is basically the pressure of SO2Cl2 plus the pressure of SO2 plus the pressure of Cl2. So you have to use stoichiometry to get the relation between all these three. So look at it this way. Like, think back to what you did in grade 11. So SO2Cl2 gives SO2 plus Cl2, right? At t equal to 0, this was all 0.5, this was 0 and 0. Then at t equal to 100 seconds, After
Oh,
100,
0.5 minus x, x and
Yeah.
x.
yes. If x has been converted, then x of this is produced, x of this is produced. So 0.5 minus x plus x plus x, this total pressure is equal to your 0.6. So based on this, find each of these things, and then yeah, you can directly put it in the equation.
Ma'am, x is equal to 0.1.
Is that x? अच्छा हाँ, एक cancel हो गया ना? There you go.
हाँ.
मिल गया. Which means 0.1 has reacted. तो कितना बचा है SO2Cl2 at time 100 seconds?
0.5.
No?
Zero. I'm sorry, wait.
था 0.5 minus 0.1.
0.4. Sorry, 0.4.
Yes.
So 0.4 of SO2Cl2 is left after. Okay.
So now you have
So now I can put it in the
yes.
R1, R2 formula. Okay,
हाँ.
okay, got it.
Yeah. Here you should not face a problem because directly logarithm apply karna.
Yes, ma'am.
Yeah. Just be careful if you're calculating with log or natural logarithm. Because if you're converting, you need to multiply that by 2.0303.
Ma'am, I've got an answer.
Is that the value of K or did you find the final thing?
No, I found the value of K.
You need to be careful when you're finding out the final thing also because 0.65 is the total pressure. It's not of SO2Cl2. So again, you need to apply the same thing to find what is partial pressure of SO2Cl2 when total pressure is 0.65 and then do it based on that.
No, wait. Sorry. I sort of lost you.
So in like once you found out K, in order to find
Yes.
rate, so the rate depends only on the concentration of the reactant.
Yes.
So it won't be K into 0.65. You need to find what is the partial pressure when the total pressure is 0.65. So again, it'll be 0.5 minus whatever y. So the total of these three will be equal to 0.65. And yeah.
So, ma'am, partial
Mm-hmm.
pressure of SO2Cl2. So if I follow that method where I go SO2Cl2, I go SO2 and I go Cl2. Okay. So now I know that 0.4 of my partial pressure comes from, my total pressure comes from SO2 Cr2. No, but
That
then
is
that's wrong.
when the total pressure is 0.6.
But the total pressure is 0.6, right?
No, but your final answer, you're asked to calculate the rate when total pressure is 0.65.
Okay. Okay.
So again, find what is PSO2 Cl2 when the total pressure is 0.65. Like 0.65. And say how much of it is because of SO2 Cl2. And then
It'll be the same thing, except it'll be like,
different values. Yeah.
yes, like hardly different values.
Yeah. So 0.5 minus 0.15 hoga. Yeah.
That's it.
Yeah. Yeah. So Shantini, you're disconnected abhi tak. What's going on? Like, have you started this question, or like did you disconnect just before this, after this?
No, ma'am, I'm solving on this.
Dhriti, yes, no, I'm talking about Shantanu.
Okay, sorry.
Yes,
Miss,
ma'am.
whatever you're saying now is coming like later to me. Some is coming at the same time when you're talking, some is coming after like 2 minutes. So that is I've kept my camera on. Sorry.
So Shantanu, if you're solving this, theek hai, but if you're yet to start this problem or something, let's skip this and then you can solve it after the class. Okay.
Okay.
Okay, Ansh, kya ho raha hai? Did you get the strategy? Like, are you calculating or are you still thinking?
Okay, I think I've got an answer.
We'll check, we'll cross check it.
Yes, ma'am.
Dhriti, where have you reached? Have you found out the value of K?
Yes, miss. Rate constant, I am getting it as 2.23 into 10 raised to minus 3.
Okay. Mitali, is that something you got as well?
You're muted, bro. You're muted.
Sorry, your voice is very faint. Can you repeat that?
2.23 into 10 raised to minus 3.
No. I am getting like the double of that value.
4 point something.
Yeah. 4 point something.
Did you take natural logarithm or log to the base 10?
I took
No,
natural
log. Wait, I did 2.303 into log.
Okay, and even when you put it in the calculator and all, you calculated log.
Yeah, I got 4.86 into 10 raised to minus 3.
Calculation. Oh yeah. No, 2.23 into 10 power minus 3 आना चाहिए.
Oh.
See, the pressure calculation and all, yeah, we kind of did it together. So, वो तो match हो रहा है. Let's see. First order के लिए K equal to, so you did 2.303 divided by
in
100.
2.y into log of 0.65 by 0.40
0.65 क्यों आया?
because that was the total. I was supposed to take just 0.6, no?
0.5 divided by 0.4. See,
Ma'am.
calculation of logarithm, like calculation of rate constant, you used only these values,
Hmm.
right?
No,
Point-
but we did find out that 0.4 was SO2Cl2, right?
Yeah. So basically, at T equal to 0, SO2Cl2 ka partial pressure was 0.5.
Hmm.
At T equal to 100, partial pressure was 0.4.
Hmm.
So this is the only data you use. K
Ah.
2.303 divided by time 100
Hmm.
into logarithm 2.303 है इसलिए I'm taking base 10. 0.5 divided by 0.4 or initial पहला आएगा ना, so 5 divided by 4. This is what you're supposed to do.
Okay, ma'am, I got it. Like, I know why I went wrong.
There are two, like keep it separate. पहला calculation of rate constant के लिए just this one. That's it.
Hmm.
Once you're done with that, then look at, okay, using K, what am I supposed to find out? Then 0.65 comes into picture, and यहाँ पे partial pressure will be 0.15, whatever that value.
Hmm.
Okay. So that's how you do it. Okay. Okay, Dhriti, you're on the right track. Mitali figured it out. Ansh, what is going on with you?
So miss, now that I found out K, I calculate the rate, right?
Rate equal to K into first order है, so partial pressure raised to the power 1.
Yes.
Yeah. Okay. Ansh Gupta, you've been quiet.
Ma'am,
Hmm?
I got the rate.
Oh, final.
Like just now.
अच्छा, उसके पहले K कितना मिला? What is the value of K? Cross check.
K, ma'am, 2.23 into 10 to the power minus 3.
Awesome. ठीक है. So you also got it properly. ठीक है. So K का value according to this, did you guys get this much?
Yes, ma'am.
0.8. ठीक है. Awesome.
Yeah, ma'am.
ठीक है. All right. We'll do a couple more.
Miss, can we take a 5-minute break and then start again?
Okay. Do you guys want to do a couple more problems based on this, or should we start off with half-life, Abhi?
Miss, can you give us questions as homework so that we can, actually spend time around say here we'll be wasting
Yes,
time.
ma'am.
We can finish
Okay.
the topic.
All right. Okay, we'll do that. No, because questions, like if you guys got a hang of it, self-practice you can do on your own. But if you need some more
Yeah,
hang,
I think we all got the hang of it. It's just taking too much time to solve one question.
okay, cool. 4:32 हो रहा है ना? Just like have some water, take a quick break. We'll resume at 4:35. Okay, 4:37. We'll just keep it like 5 minutes. Assuming. Okay, just like how we saw zero order reactions you could find in like enzyme catalyzed things, like reactions that happen on metal surface. First order reactions, we'll look at a couple of examples just to give you an idea. So example 1, where will you find first order reaction?
And here also we'll look at categories under which reactions fall.
No, we'll have like specific things.
Okay.
One of them is a category, okay? So all radioactive so radioactivity. So basically, disintegration of nucleus, like wherever there is radioactivity, like radioactive reactions follow first order reaction, like first order mechanism only. Let's call it radioactive decay. Yeah, decay is the word I was looking for. So radioactive decay of nuclei always follows first order reaction. So uranium breaking apart, helium breaking apart. So wherever you have like radioactive decay, like carbon 14 getting converted to carbon 12, wherever you have radioactive decay, they all follow first order mechanism only. Absolutely. Then where else? Hydrogenation of ethene, hydrogenation reaction follows first order mechanism. So remember hydrogenation, like this is again, this happens over a metal surface like nickel, palladium, platinum. You need a catalyst for that, yet it's not like a zero order reaction. So it's not a hard and fast general rule, but that's like the tendency because that's how the dependencies are. This is an outright, like you see radioactive reactions, like radioactive decay, it's definitely going to be first order. Okay. Before we get to half-life, there is something else that we'll look at. So there's something called pseudo first order reactions.
Then that's it, only 2 examples.
Yeah, for now. Third example, you saw like SO2Cl2 happened to be first order. Yeah.
But that was just like another, like,
Yeah.
yeah.
So like just remember 2 examples just in case you get a subjective question or something like that. But
Okay.
yeah, otherwise, like again, there's so many millions of types of reactions happening in the universe. We can't categorize every single
Yeah,
thing.
correct.
Remember 2 or 3 in each, and that's enough. All right. So what do you think pseudo first order reactions are?
Well, first order reactions where x plus y is equal to 1.
I mean, those are regular first order reactions.
Yeah, regular.
Pseudo bit. Like, why do we call them pseudo first order reactions?
They might mimic.
So they are, they mimic first order reactions, but they are actually not first order reactions. Okay, so pseudo first order reactions are basically the reactions that behave that behave like first order reactions.
We haven't seen any behavioral traits of first order reaction.
We'll get into it. Like, what do we mean by why, like, where do they come across is because of the reactions conditions that we ourselves take.
Okay.
So they behave like first order reactions. See, behavior of first order reaction matlab dependency on only like one reactant to the power of 1, concentration of reactant to the power of 1. That's what it ends up being, no? So behavior like first order reactions, but they are actually not first order reactions. Okay. And this happens due to the reaction conditions that are taken. Yeah, this is quite important. Like, that's the reason why they end up being first order reaction. If you take reaction independently, like if you just let it happen naturally, it's actually not. But the way we end up doing these reactions, it just happens to be first order. Like, for example, hydrolysis of esters. So hydrolysis of esters. Do you guys remember what esters are?
O, as in R bond O bond R dash, right?
They're ethers.
Or so R bond C double bond O R dash. It's
Correct.
either this or that. It can't be anything else.
Yeah. So let's say, like, for example, if we have ethyl ethanoate, CH3, COO, C2H5, C double bond O, and R dash. Hydrolysis is basically treated with water in the presence of acid. So what you end up getting is this turns back into acid, and the alcohol,
Yeah, acid and alcohol.
yeah, it's made up of.
The other way around is esterification, right?
Yeah. Formation of
Okay.
ester is esterification. Hydrolysis of esters, it decomposes back into this. Okay.
Okay.
So this is actually a second order reaction, but generally we take H2O in excess. So imagine, like, when we are doing a reaction, we take a beaker. We don't measure out the quantity of water also, right? Like, whatever is the reaction medium, we take that reaction medium and then add the special reactants into it. So in this case, I take a beaker full of water, add, whatever, like 1 mole of ester plus 1 mole, a couple of drops of H2SO4 maybe. So this ends up being a first order reaction, because since we take infinite amount of H2O in comparison with the other things that are present, it doesn't really matter. The concentration of H2O doesn't really matter. So ends up being a first order reaction because of that. Okay. Is this clear?
Yes, ma'am.
So because H2O is in excess, the rate ends up being K into the ester ka concentration alone. Okay, similarly, there's a second example. Once you're done noting this down, I'll put it in the next page. Okay.
Yes, ma'am, done.
Okay. Jyoti,
So, ma'am,
One
anything that is taken in excess, we don't count it in the rate of the reaction.
yeah, because think about it, ends up not mattering because it's like just there everywhere. So the rate of the reaction is not especially affected, because, like, think of it as, okay, water is taken for granted, so you don't really have to, whether you add,
Included.
yeah, it doesn't matter whether you add more because there's a lot of it. Even if you take out a little bit of it, doesn't matter because there's a lot of it.
Makes sense.
Yeah.
And ma'am, the other example is?
Other example is inversion of cane sugar. So once everyone is finished noting it down, I can flip the pages here.
done, ma'am.
Okay. Ansh and Chandra have been awfully quiet, not switching on video also. So I don't know what to do with you guys. Should we go ahead or not?
Yes, ma'am.
Okay, Shantanu. Just be a little faster with that, guys. Otherwise, I don't know where you're at. So, inversion of cane sugar. Do you guys remember the formula of sugar? sugar. I'll give you a hint. That's sucrose. C12H22O11. So same funda, mix it in water, put a little bit of acid. This breaks down into glucose and fructose. Glucose, fructose have same molecular formula, but yeah, they're two different things. You guys have seen. So once you're done, we'll start with half-life. Half-life is like,
Done, ma'am.
yeah, it's a very, very important
Done,
concept. Practically speaking, it has a lot of applications. Okay. So looking at the word half-life, what do you think half-life of a reaction is?
Ma'am, in radioactive terms, half-life essentially means that it's the amount in which, so if I start with A, so after like there is like half-life of that particular substance, a particular chemical A, after which like that period, after that amount of time, it will become A by 2. Like it'll become half the
So
amount.
I guess what half-life of a reaction would be that after a certain point in time, the rate, like if my rate is 100 moles per second of production, then it would become 50 moles per second production. I guess. I mean, I'm not sure.
Close, very, very close. It's not the rate, it's the concentration only that becomes half. Like whatever you have in, see,
So I
radio,
was pretty close.
yes.
Oh, so
very
because
right.
rate remains constant.
Yeah. For zero order, it remains
Ah.
constant. First order, it depends on the concentration. But conceptually, see, radioactive decay is essentially a first order reaction, right? So half-life is a concept that's applicable to all the reactions. The same concept. Yeah. So it's basically the time taken or the time in which the reactant is halved. The concentration of the reactant is halved. So as Mitali put it, so agar if you took A amount of the reactant, half-life is basically the time for that A to become A by 2.
So, ma'am, the rate of the reaction remains constant.
So that
throughout,
depends
right?
on the order of the reaction, whether it's first order.
Yeah.
Yeah.
Acha.
The time in which the concentration or concentration, if you had to write it in different words, is reduced to half of the initial concentration. Same thing, different words, that's it. So half-life is represented as T1 by 2. So wherever you come across T with 1 by 2 in the subscript, so that's basically the half-life car, the variable like that you used to denote it. Yeah. So now this whole section of half-life deals with how do you find the half-life for a zero order reaction and how do you find the half-life for a first order reaction. So we'll derive the formulas and the numericals will be that only, like half-life for this reaction is so and so. So for what is the rate constant or what is the initial concentration, like it'll revolve around that.
Okay.
Yeah.
So, what do we start with? Do we start with like a rate equation?
We'll start with zero order reaction. So remember, half-life is basically the relation between time and concentration of the reactant. Okay, so what rate equation of zero order reaction like will you use to figure out the half-life? So will you use the differential form or will you use the integrated form?
Integrated.
Integrated.
So R at a particular time t is equal to R naught minus KT.
Yes, R is equal to minus KT plus R naught or R naught minus KT, whatever, same thing. Okay. So for us, like for half-life's sake, at t equal to t half, what do we know about the concept of half-life?
That R is equals to R naught by 2 minus KT.
Hey, R naught by 2.
Yes, R naught by 2.
You already like substituted it over here. Yeah.
Huh.
At t equal to t half, half-life ka meaning when this much amount of time has passed, the concentration of reactant became half.
So ma'am, what about minus KT?
No, this is our concept. Now we'll substitute these values in this.
Oh, okay.
Value is
So R is equals to minus KT half plus no. R naught by 2 is equals to minus KT half plus R naught. Right?
Yeah.
Oh.
So rearrange it and tell me what do you get? Like if I want to find T half, what is my formula for that?
Ma'am, T half is like an entire entity, right? We're not separating that.
No.
Yeah.
Just T half.
So R naught by 2 minus R naught, the whole upon K.
Solve that.
Oh.
R naught तो एक ही है.
So it'll still be like R naught by 2K.
Okay. Dhriti, Ansh, what you guys get? Shantanu?
Ma'am, will it be? No, so it'll be R naught by 2K, right? And that is equals to T half. There'll be no minus because they'll get cancelled out. Okay.
Right. Shantanu, Ansh, Dhriti, you guys getting this? Kya aaya?
Yes, ma'am.
Okay. ये पूरा like mathematics ही है, basically. So this is your expression to find out the half-life of a zero order reaction. Okay, so T half, like half-life is equal to, it is just initial concentration divided by 2K. So you can see that the half-life is directly proportional to the initial concentration and indirectly proportional to the rate constant. So if you have to compare two different reactions, you can, like, or if you see, if you take initial concentration, when K is constant, एक ही reaction के लिए, if I take 4 grams of the reactant एक case में and then 2 grams of the reactant A दूसरे case में, the 4 grams one will reach 2 grams first before the 2 grams reaches the 1 gram part. And if you have to compare two different reactions, like suppose R naught is constant, I take 1 molar HI and 1 molar NH3, and if I want to compare the decomposition for both, जिसका भी rate constant ज़्यादा है, that will take more time to get to half the thing. Okay, so that's kind of how you can use it for analysis.
Yes, ma'am.
Similarly, let's derive for first order also, and then we'll do a
Yes, ma'am.
later. Yes.
So, ma'am, first order will use the same.
Yeah, just that ye wala equation will change. Conceptually, it's the same. At T half,
Hmm.
R0 becomes R, like the reactant ka concentration becomes R0 by 2. So substitute the values and do the math, like rearrange it so that you get T half on one side. So T half for first order.
Ma'am, so here we'll use
Either log or log.
t is equal to 0 or t is equal to specific time.
T equal to T half. Because half life के बारे में बात कर रहे हैं ना.
No, as in, will we be using, but like,
So this is the original like main equation.
yeah, minus kt plus ln r0.
Hmm.
Yeah.
T
So
is a
we'll use that only, right?
variable. Huh. So at T equal to T half, when T equal to T half, concentration becomes half of the original. So do the same thing. So ln of R0 by 2 is equal to minus k T half plus ln R0. Let's just go rearrange कर लो. So if I get this over here, I get k T half equal to okay. Let me know when you guys reached. If you're confused at any step, tell me. We'll pick it up from there. But
Miss, not confused, just writing.
ठीक है. Now just say, like if you're doing it, like solve it, verify what you got in the end, and wherever you're stuck, you can ask.
Yeah, ma'am, and can you just explain the step above the red box?
Oh, so this is again logarithms ka this thing. So log A minus log B is equal to log of A divided by B, right? So that's
But we had like 2 as well.
huh.
2 went up. Acha, okay.
A minus log of A by 2 hai. So this becomes log of A divided by A by 2.
Yes, ma'am. Then it goes up.
Ho jayega. So this gets cancelled. Yeah. So an interesting thing, like once you're done with this, we'll just talk about this particular reaction, and then this particular equation, and then we'll get on to solving a couple of problems.
Yes, ma'am, done.
Done. Okay. Dhriti and Ansh?
Done, ma'am. Mitali, if you're talking, you're mute.
Ansh Gupta.
Ma'am, I'm done, ma'am.
Okay. So if you compare it with zero order, so यहाँ पे R naught भी है, T half के लिए K भी है. In this, T half is directly equal to this particular number divided by K. So like this, iska observation is it is independent of the
Independent of
concentration. So it doesn't matter how much concentration you take, it will always take the same time to become half of whatever it was. So
it just depends on the substance, right? Because the K
it depends on that
K
particular
changes.
reaction.
Yeah. So, ma'am, because we know that K is temperature dependent, does half-life also become temperature dependent?
Yes.
Okay. So half-life in general is temperature dependent, right?
Yeah.
Okay.
That's indirect because temperature affects the rate of reaction. So the faster it is, the faster it'll get to half of the concentration. Yeah. But an important thing, like interesting thing to note is that it is independent of the initial concentration, which is why if you consider radioactive decay, it doesn't matter where that decay is happening, how that decay is happening. If you have
It will become half no matter what.
Yes, like it'll take the same amount of time to become half of the initial concentration, which is why carbon dating is so reliable, so helpful. Like you don't have to worry about so many variables. The reaction is the same thing, C14 converting into C12, so K constant rahega hamesha. So it's very easy to do carbon dating because you don't have to worry about what is the initial concentration and all those other conditions. So if you know the final concentration, you can work backwards. Like iska double is always, it happens at so much amount of time, and double of that quantity is again the same amount of time. So those many half-lives have happened. Yeah. So as you do a few problems, you'll get used to that. Okay. So it's 5-7. Do you want to focus on questions based on like the first order, zero order reactions and the half-lives?
Yes, ma'am, we could like do one or two. But ma'am, before that, I just wanted to like clarify a thing. Tomorrow, because we have like a holiday in school,
Okay.
it's Makar Sankranti. So can we take the class in the morning or something like that?
Whose class is
No, yaar. 11 to 2, I have my IMS.
Oh, tomorrow also we have chemical kinetics only.
Yes, yeah. That's why I was just
Oh,
like,
so we have time. We'll finish the chapter. So when are all of you free? Dhriti, what did you say? Morning?
I would prefer if like I get free towards like the
Morning,
evening.
I mean, I don't mind 9 to 11 or 9 to 1. But
Okay.
No, but don't you have class? Or didn't you say that?
9 to 11, no, 9 to 12. I have classes from 11:30.
11:30.
So, आधा घंटा is okay.
Ma'am, I am okay if you take it in the morning.
Okay. If we were to finish chemical kinetics, plus temperature dependency hai, catalyst dependency hai, 2 hours is sufficient. So even if we get extra time, I'll spend it on questions and problems only. So you can do either way. Ansh and Shantanu, what about you guys? When do you want to take a class tomorrow?
Fine with any time.
Fine, anytime. Okay. Ansh, what about you?
I'm same anytime.
Anytime. Okay. So do you want to do 9 to 11? Khatam kar lete hain,
Yes.
so you guys also will
Um,
have the rest of the day if you want to continue with questions. Right?
And Miss, it's just a suggestion. But once, like for every subject, physics, chemistry, maths, once we finish one chapter, can be like the next week. If for example we finish this week, so probably next Friday or somewhere in the next week, can we have like a mock test so that we are actually studying for it and not doing
Definitely.
end moment.
Yeah. So I was thinking we'll have one every Sunday. So
Cool by me. Matlab every now if this week's cover, so this coming Sunday or next Sunday?
this Sunday we can keep one on atoms, and chemical kinetics I can restrict it to the first topics, before, like, based on rate of reaction alone.
Okay. Yeah, that works.
We'll exclude half-life, and maybe we can include zero order first order reaction.
Because if there are two tests together, just keep till topic practice 2.
Yeah, that works.
Because if you're doing atoms and this, then it becomes a little heavy. I'm just
Maybe half of the chapter. No, half-life definitely will not come. The part before that I was considering, but yeah, topic practice 1 and 2 tak we can keep it. Yes.
yeah.
Okay, ma'am. So will this be like a subjective objective mix sort of a thing, or like a
It'll be
On
Objective.
PNP,
objective only.
no,
Like it'll be on
PPI.
yeah, PBIC only.
ma'am? Can I request you to make it subjective?
Yeah, a little
Because
subjective because this term we'll have all subjective.
and we haven't done anything subjective related in over a year now. I
We
think.
need writing practice.
मतलब yeah, I get your point. Subjective मतलब correct करके वापस करना will take some time. It's a little bit of a
Ma'am, that
Then-
is all
but
right.
that is okay. You can take your time to correct and send it. Just keep, you keep objective also so that we know that our concepts are fine.
So
But
we'll do
keep,
one thing. Abhi, like immediately when a chapter is over, we'll continue with objective, and then
Yes, ma'am.
take a whole unit at a time. Like when we do practice test, 2-3 chapters together or something like that, then we'll have like subjective tests.
Okay,
okay, fine. Yeah.
that sounds good.
Okay. So tomorrow class we'll have it from 9 o'clock.
9 to 11.
Okay.
Okay.